Welcome to Aerodynamics in Minutes. In this video, we are going to talk in detail about the lift and drag force equations. These are the lift and drag force equations used in the year 1900 to 1905, and these equations evolved. The lift and drag force equation used today is lift is equal to coefficient of lift into half into density into velocity squared into area, and the drag is equal to coefficient of drag into half into density into velocity squared into area. In order to find how these equations came into existence, let us see some observations from the aircraft data. Plotting lift versus velocity, we can find that lift increases as velocity squares. Therefore, lift is directly proportional to velocity squared. The faster the airplane flies, the more lift it produces. And if we plot lift versus lifting surface area from a particular aircraft data, we can see that lift is directly proportional to A, that is area. The more lifting surface the aircraft has, the more lift it produces at the same speed. In the same way, plotting lift versus density from the same aircraft data, we can find that lift is directly proportional to the density. And this density is the major reason why hydrofoil produces more lift than aerofoil, keeping all other parameters same except density. Putting all together, and for taking the proportionality outside, we introduce two constants, half and the coefficient of lift. Similarly, plotting drag versus velocity, we can see that drag is directly proportional to velocity squared. Plotting drag versus area gives us drag is directly proportional to area, and similarly plotting drag versus density gives us drag is directly proportional to density. Putting it all together, drag is equal to coefficient of drag into half into density into velocity squared into area, where CD and half is introduced to take out the proportionality. For an airplane, the coefficient of drag encapsulates all the complexities. Before breaking down the coefficient of drag, we must know about the wing tip vortices. These vortices are generated due to the pressure difference between the upper and the lower surface of the wing. These vortices reduces the effective radial ratio of the wing, and the span of the wing is the total length of the wing. The area ratio of an aircraft can be found using the formula span squared divided by the wing area. The larger the area ratio for a specified wing area, lesser the magnitude of vortices and lesser the drag. Therefore, CD is equal to CD0 plus CL squared divided by pi into area ratio into efficiency factor, where CD0 is the sum of skin friction drag and the formed drag, where CL squared divided by pi into area ratio into E is the lift induced drag. It is on top CL square. CL square is on top because the pressure difference above and below the surface of the wing increases as the CL increases, which results in more vortices and more drag. And I had a question for you. Who formulated these lift and drag equations? And the answer for this question is displayed. Did you find? I can wait. And the answer is no particular one. And these equations came from nowhere as far as I have searched. This is Dhyanish signing off in Aerodynamics in Minutes. See you in the next video. Stay tuned.